Hi everyone, my name is Yong and I am from Group Luffy. These are my team members, Yuan, Lim Jinghui and KHAI. Today, my group are going to present to you the study performance of gas turbine power plant. So, let's get started. The first world's gas turbine was built in 1903 by Aegidius Ealing. By using the combination of motor, generator, single combustor, compressor, and turbine, this gas turbine can produce about 8 kW power. Next, gas turbine was widely used in aircraft industry and industrial applications like power plant. In aircraft industry, the output of the gas turbine is used to turn the compressor. The hot air flow leaving the turbine is then accelerated into the atmosphere through an exhaust nozzle to provide thrust power. While gas turbine in power plant basically involve three main sections, which is compressor, combustion system, and the turbine. The compressor is used to draw air into the engine and then pressurize it and feed it into combustion chamber. Then, fuel injectors that inject a steady stream of fuel into combustion chambers to burn the mixture. The combustion produces a high temperature and high pressure gas stream enter through the turbine sections and spin the rotating blades and also the generator to produce electricity. In 1872, George Barry Brighton introducing a new concept into gas engine which called Brighton cycle. Brighton cycle replaced the combustion chamber and exhaust process from open cycle into heat exchanger to make the working fluids rapidly circulated through the machine, also called closed cycle.
Hi, my name is Arifin and I will be presenting the schematic diagram and explanation in this journal paper. So the first schematic diagram that we will be discussing is the open cycle gas turbine power plant. Firstly, the fresh air from the environment will enter the compressor, and when the compressor rotates, the fresh air will be compressed into the combustion chamber. In the combustion chamber, the compressed air will be mixed with the fuel and the process known as combustion process will take place. And this combustion process will produce exhaust products at high temperature and high pressure, which will be used to rotate the generator at the turbine, and eventually this exhaust product will be released back to the surrounding. So next we will look at the closed cycle gas turbine power plant. The closed cycle is somehow similar to the open cycle, and the only difference is that instead of releasing the exhaust product back into the environment, the exhaust product from the turbine will enter the heat exchanger for the heat rejection process, and after that the cool air will enter the compressor again for the compression process. For the regenerative cycle, the regenerator will be added between the compressor and combustion chamber. The main function of the regenerator is to preheat the air before it enters the combustion chamber. Besides that, it will also recycle the hot gas that is released from the turbine, and this process will increase the thermal efficiency of the cycle. Now we will look at the last schematic diagram of the journal. Both high pressure and low pressure compressor and turbine will be used. An intercooler is placed between the compressors, while reheater is placed between the turbine. The main function of the intercooler is to cool down the working fluid, while the main function of the reheater is to increase the temperature of the working fluid before it enters the turbine. And both of these processes will increase the thermal efficiency of the cycle greatly. Now, I will also present the method of performance analysis in this journal paper. Some of the method of analysis used in this paper are table, diagram, equation, and graph. So firstly, the ideal gas air table will be used to determine enthalpy of the data provided. After that, the PV and TS diagram will be sketched according to the data obtained from the table. And thirdly, equations will be used to determine the heat input, heat output, work input, and also work output of the cycle. And this data obtained will be used to determine the thermal efficiency of the cycle. And lastly, a graph will be used to analyze the effect of ambient temperature on the performance of the gas turbine. That's all from me. Thank you.
Good day, everyone. My name is KHAW from Group Luffy, Session 9 Group 2. From the previous explanation about the methods of performance analysis, I am going to discuss about the performance calculation of the system. In the following discussion, I have prepared two types of situations to explain how to calculate the performance system with the aid of TS diagram and also the thermodynamics table. There are two types of situation to be discussed, which are ideal and actual gas turbine cycle respectively. There are some assumptions made for the flow system for the fair performance calculation of the system. Here is the assumption for the ideal gas turbine cycle, while here is the assumption for the actual gas turbine cycle. And here is a TS diagram of the both cycle. For the performance calculation of the ideal gas turbine cycle, we need to determine all the enthalpy values, relative pressures, and unknown temperatures for each state by using the ideal gas air table and following the assumptions. Here is the working for all four states of the cycle, and some interpolation are required for the calculation. After we have calculated the following enthalpies from enthalpy 1 to enthalpy 4, we could determine the work input for the compressor, work output for the turbine, and also the heat addition of the system as shown. Then, we could determine the performance of the ideal gas turbine cycle by using these thermal efficiency formulas and substituting all related values to solve for thermal efficiency. Same to the actual gas turbine cycle. Instead of previous enthalpy values of the ideal gas turbine cycle calculated, we need to determine the actual enthalpy's value for state 2A and state 4A respectively as following. By following the assumption made, here is the working for both state 2A and state 4A respectively. Next, after calculated all the required enthalpy values for all states, we could determine the work input for the compressor, work output for the turbine, and also the heat addition of the actual system. Then, we could determine the performance of the actual gas turbine cycle by using this thermal efficiency formula again and substituting all related values to solve for its thermal efficiency. TS diagram shown is the data label TS diagram for both ideal and actual gas turbine system. Based on the performance calculation, we could proclaim that the ideal gas turbine system has better performance than the actual gas turbine system.
Hello everyone, my name is Lim Jing Hui and come from Section 9 Group 2. Today, I am going to talk about the suggestion on system improvement of gas turbine power plant. In terms of gas turbine performance, the inlet and exit condition of gas turbine can determine its performance based on its power output, thermal efficiency, and fuel consumption. So, the first suggestion is to make improvement on the factor that influence the performance of gas turbine, such as the ambience and operation condition of gas turbine, and improving the compressor pressure ratio and turbine inlet temperature to ensure that there is an increased efficiency of the component of the turbo machinery. Then, the second method is by modification of the basic gas turbine cycle, for example, by adding intercooler, regenerator, and reheater. Next, there is a study on the effect of ambient temperature, exhaust gas temperature, and ambient pressure on the performance of gas turbine power plant. Here is the graph of the study. So evidently, an increase in the ambient temperature will cause a decrease in the power output. An increase in the air ambient temperature from 15 degrees Celsius to 30 degrees Celsius will decrease the net power output by about 10%. And adversely, when the ambient temperature increases, the heat rate and the exhaust temperature increases. So, from the graph, we can conclude that the optimum temperature for the 100% performance of the gas turbine power plant is at 15 degrees Celsius at a relative humidity of 100%. Secondly, is by modification of the basic gas turbine cycle. We will compare the performance of gas turbine for three scenarios, which are gas turbine with intercooler, gas turbine with regenerator, and gas turbine with intercooler plus regeneration plus reheater. And we have made some assumption in order to get the thermal efficiency comparison. Here is the assumption made for the gas turbine with intercooler. This is the gas turbine with regenerator, and here is the gas turbine with intercooler plus regeneration plus reheater. Then we need to find all the enthalpy and pressure relative for each step in order to get the performance of the turbine system. Then here is the comparison of performance between three gas turbine systems. So the highest performance is the gas turbine with regenerator, followed by gas turbine with intercooler plus regeneration plus reheater, and then is the gas turbine with intercooler. This can be explained that with only intercooler or regenerator, we cannot achieve higher performance of gas turbine. But when we combine them together, we can achieve a higher performance of gas turbine. That's all from our group. Thanks for watching. Goodbye.